All right, glad to know that you are still with us. The program is Engineering and You, sponsored by Prince Engineer Yemisi Shilon, FNSC. My guest for today is Engineer Dr. Pampa, FNSC, and he will be talking to us on a very, very interesting topic, very interesting one, I must say, and the topic is the evolution of engineering from the ancient time to the modern era. That I'm curious about. I want to know what that topic really entails. First of all, you're welcome to Engineering and You, sir.
Thank you very much.
All right, so
good evening, viewers.
You have the floor. I'm really curious, the evolution of engineering from the ancient time to the modern era. Please,
yes, thank you. So, viewers, we shall be discussing today engineering, its evolution from the ancient time to this present era. And we will start by defining what engineering is, the nature and characteristics of what we can say, who we can call an engineer. And then we go on to discuss the early products and devices associated with engineering. And then we look at our environment and see evidence of engineering around us. Then we'll go on to discuss the things we need to do as young lads, as young boys and girls, to get into the engineering training proper, the kind of academic knowledge we need to have, the hands-on skills we need to have, and then go on to discuss also other skills, life skills that add value to whatever anyone is learning. So I promise you that you're going to find these things interesting. So first we'll start with what is engineering. So engineering is defined as the application of knowledge of science and mathematics to solve human problems, produce devices, services and systems that meet the needs of society. And what is the nature of engineering, or what characteristics can we say, can we associate with engineering? Like I said, we are applying the knowledge of science and mathematics to produce goods and devices that solve problems. It means, for example, that we must have, the engineer is both a scientist and a craftsman. Scientist in the sense that everything he does has a concept, has a basis, and has a theory behind it. But not only that, he must then be a craftsman in that he must be able to fashion out the devices, produce the actual things that solve these problems. You can see the slide there. You have the image of a scientist. That lady there is in an electronics lab. And then on the right of the screen, the slide there is of an industrial welder. These two things must go together to produce an engineering product. So that's the nature of engineering: science and craft, knowing and doing, theory and practice. So now we are talking about evolution from the ancient times. And the best example of engineering in the ancient time can be traced back to the Roman Empire. The kind of devices that were associated with early Roman Empire. And we look at, if you look at the top right of your screen, you will see what is called an aqueduct. This is an early example of a water channel, delivering water from its source to the cities. Not only to cities, but to the Roman armies in their camps, in their locations. You can also see the design of the arch there. You know, these are typical of Roman architecture. Roman architecture, Roman era engineering. On the bottom slide, you have, on the left side, you have what is called a siege engine. In those days, you know, ancient warfare, they will lay a siege on a city. That city will be defended, will be surrounded by a defensive wall. So while the attacking forces will be trying to break down the walls with their siege engine, the other people on the other side will be using the same siege engine to launch fireballs across the fence against the enemy forces. So this siege engine was very important in those days. and it's typically an example of Roman engineering at the time. On the bottom right screen, you have the water wheel. This water wheel is an early example of a mechanical force that was used in grinding corn, grinding wheat, barley, flour mill, and the rest of it. Once the wheel moves, just like you have in modern times, you see there's nothing you grind in which the wheel does not move. So this is an early example of a moving wheel. You can see a building beside you. That's a factory. The moment that shaft is able to turn inside the factory as well, many things can be done with the mechanical power so produced. So now Africa is not left behind. You see the early example of engineering or engineering craft in Africa is in the blacksmithing. Blacksmith, the bronzesmith. You may have been hearing of some artifacts that were recently returned to the Benin Kingdom. It was taken away by the Europeans at that time. They so much liked the bronze statues, and they took them away. And these bronze statues were made from bronze. And in order for you to make material out of bronze or artifacts out of bronze, you must know the characteristics of that metal, apart from also having knowledge of furnace construction. Not only in Benin, Benin and Ife, these are twin civilizations. So those two are examples of the use of blacksmith, bronzesmith to produce artifacts that are products of engineering. On the right side of the screen, you have the loom. That is the mechanical device at that time, and even now is still in use for weaving cloth. It's a cloth weaving loom. This one is called a single hair loom. You can see the woman there squatting, making the thing. As simple as it is, that's how Ashoke is still made up till today. So now, from the ancient times now, look at how engineering has developed into its different ramifications. So water is delivered to your house because there's a dam somewhere. In Abeokuta here, we have the Arakonga, and there is a water works somewhere, still in Arakonga, where these things are treated and pumped, electromechanical devices through pipelines to your homes. That's an example of engineering. We are no longer using aqueducts of the Roman era. We are now having pipelines, either PVC pipelines or steel pipelines or cast iron. We have several other things as well. You have robotics. You have your phones. You have a lot of roads, bridges, and big industries. You have them on the Benin Shagamu, industrial hub, for example, Abeokuta, Shagamu. You have Nestle, all these companies there. These are all examples of engineering industries using the modern technology, how it has evolved from that time to this time. We have shown you some products of the ancient times. Let's now go on to the things we can see around us in the modern era. So you have there are 4 slides here you can see. On the top left is the Lekki Deep Sea Port. That Lekki Deep Sea Port is an engineering marvel. It combines both the knowledge of waterfront structures that a civil engineer would be expected to have or develop as a specialist skill, together with many other electromechanical devices that go into cargo handling, ship handling, and the rest of it on the Lekki Deep Sea Port. We have specifically picked the slides from Nigeria so that you can relate with them and know that engineering things are happening right in our environment, and it's waiting for you to come on board, build more, and sustain even what has been built. On the top right side, you have the Dangote refinery, the much talked about Dangote refinery. That's a snapshot from Dangote refinery, and you know that fuel, PMS, diesel, These are the lifeblood of modern civilization, without which everything will grind to a halt. This is another example of an engineering product. And right here in Abeokuta, you have an example of engineering in the bottom left. That is the Professor Wole Soyinka train station. You can see the terminal building there. You can also see the railway building, railway construction, both the track and the train itself, the engine itself. These are all products of engineering. On the right side, you have in Lagos, Lagos is rather advanced in the area of rail transportation, and that bottom right side is the overpass, like the flyover bridge over the Lagos Rail Mass Transit project. In the background of that slide, you will see a train. You also see on the curved part of that background, that is the rail track for the train that passes. You can see the bridge flying over that railway. These are all the exciting projects that are products of engineering, not only in the present age, but also in the environment in which we live. So now, still going on to products of engineering, you have the printed circuit board in the top left corner. These are the components that go into your electronic systems, your computer hardware, even your television, and the rest of it. These are, typical printed circuit board without which nothing is possible in the modern era. And you have the telecom mast. I'm sure many of you will call in today, will be calling in through GSM. These are the masts that receive and transmit the signals that enable you to communicate with us and for us to receive your communication. And of course, on the right side, you have robot. Robot is the in thing now in the modern era of engineering, and that's just a typical example of a robot. So now, how do you become an engineer? So we have divided it into 3 skill sets. You have the academic knowledge, your physics, chemistry, mathematics, and English. These are your UTME subjects. Whether you want to go to the Polytechnic or to the university, these are your UTME subjects, compulsory. Now, in addition to that, on the second line, you have further maths, agric science, biology, technical drawing. So these are things you have to add on to make your 5 credits. Some universities insist on further maths as a compulsory subject, particularly University of Lagos. So if you are aiming at UNILAG, you must take further maths as a compulsory subject for your West African School Certificate, your SSC, and not an optional subject. That's for UNILAG and maybe 1 or 2 other universities. But generally speaking, any of those subjects on the second line would be enough to make the 5th subject for your school certificate. So you now have again the practical hands-on skills. Remember I said that engineering is both science and craft, whereas the academic knowledge gives you the science of it. You have to also have knowledge of the craft. Nowadays, the emphasis is that we should not leave craft work to the roadside person, informally trained person. You don't get a good product that way. The emphasis is shifting now to also having engineers who are academically trained to also have some hands-on skills that can be helpful, that are relevant to whatever area of the discipline of engineering that he has chosen. So welding and fabrication is virtually common to all engineering. Carpentry, plumbing, masonry, tiling, electrical installation, GSM repairs, refrigeration and air conditioning, electrical equipment repairs. Anytime you have opportunity of moving close to those who are in that field, those so-called roadside technicians or craftsmen or mechanic, spend time with them, try and learn as much as you can learn from their skills. As a matter of fact, the NUC and that is National Universities Commission and the National Board for Technical Education, they are beginning to introduce these hands-on skills and making them compulsory for anyone who is going to graduate as an engineer, either in a polytechnic or in a university. So the earlier you're able to attach yourself to any of these tradesmen, the better it is for you as an engineer who wants to be competent and be globally recognized. So now, after you have grabbed the academic skills and the hands-on skills, the life skills, these are general, you know. Communication skills, verbal and non-verbal. Not everything has to be said, and even what is said must be well articulated. Either, you know, when you say verbal, it means you speak. Non-verbal could be body language, it could be written instructions. You must be good at those things, because as a leader, in the end, an engineer is a leader. As a leader, you must be able to communicate properly to your team. You must be able to relate well with your team. And that takes me to the social and emotional intelligence. Knowing the feelings of people, being sensitive to other people's feelings, being a leader, a team player, somebody who can work well in a team, as well as lead and motivate the team to achieve the objective. You can see the things we showed you of engineering in the modern era. These are complex systems. Look at the Dangote refinery, for example. You know, look at the Lekki Deep Sea Port. Look at other things. You have people working together, thousands of them. You must communicate with them, you must lead them, you must motivate them. All this you need to do with, these life skills are important in that respect. Now, how do you get there? We have told you what you need. How do you get there? So after you've, passed through the academic, learning, so now you go to the polytechnic, can go to university. After any of those two, you still need practical experience. Apart from the hands-on skill of plumbing and so on, practical experience means that you're actually part of a team that is delivering an engineering product or producing an engineering device, and of course it must be professionally certified. NSC, COREN. NSQ is National Skills Qualification, which is linked to your practical hands-on skill. So in conclusion, we have said that the evolution of engineering, from the earliest times to now, is as a result of the effort and innovation, ingenuity of engineers. The progress of mankind going forward will depend on continuous input of the engineer. The engineer can never be out of job. Therefore, my young viewers, if you wish to be relevant in the society of today and the future, take a career in engineering, acquire hands-on skills, even at the basic level. Don't forget the life skills, and you will forever be relevant and be at the top of society. Thank you all.
All right, thank you so much, Engineer Dr. Hamid Apampa, FNSE. Thank you very much for that exposition, as it were. I'm sure someone out there is in between choices of what he wants to do will then be encouraged to just go to the sciences as a starting point in your O level and move to engineering as you pick up the JAMB form and you discover that you are going to be enjoying what you are doing. It's something that is practical and practicable. But before we go, our time is almost up. I want to ask you one or two questions. Number one, back then, in the study of engineering, we have some few engineering courses. If you are going for mechanical, for example, you are studying mechanical engineering. If you are going for civil engineering, you go for civil engineering. But nowadays, you are seeing a marriage. What brought about this?
Okay, what has happened is that as society evolves, things become more complex, and you need more time, you need more specialization for people to be able to devote more time to those disciplines. Engineering started, for example, as one, military engineering. So it was the same. It was called engineering, military engineering, by the Romans. Later, civil engineering came out because there was need to apply some of those skills in peace times. like taking water to the populace, like building roads and buildings. Then when the electricity was discovered, that one became now extracted from mechanical engineering. So people to concentrate on electrical. Then when when people had more knowledge of the electron, then electronics came in as it came in. You now have computer engineering as a separate discipline. So even in mechanical engineering now, you have mechatronics, which is a combination of mechanical and electrical electronics. That's where the robotics now is even coming in, and so on and so forth. So it continues to evolve. Even civil engineering now, you now have people specializing in only structural engineering as a discipline, not just general civil engineering. Understand? So it will continue to evolve as society develops.
All right, I wish you had more time. Thank you so much, Engineer Dr. Abeokuta, FNSC, for coming and doing justice to the topic, the evolution of engineering from the ancient times to the modern era. I was about asking you, are there challenges on the ancient times that you are still facing right now? But our time is up. We have not received any call, neither have we received any messages on our question for the day, but we hope to get you to drop your answers before the question is still open and it's still on. But the question for the week is, which of the following materials has the highest conductivity? Which of the following materials has that's the answer to the question for the day, but that's the question for the week on your screen. Just engage us. The conversation continues on our various social media handles. So please, if you get the answer to these questions, you are sure to get your prize, courtesy of our sponsor, Prince Engineer Shillon, FNSC. Well, our time is up. That's the size of the program. Many thanks to you for joining us for the past 20-25 minutes. I'm sure you enjoyed the program. I'm sure you learned one or two things. Next week is another time when we'll bring you another guest to discuss another topic that will educate you and inform you. Until then, my name is Tunde Laniro. Bye-bye.